Basic Concepts of Probability, Finite Math, Chapter 8, Section 4. All right, now we've had some background information on probability. Now we're going to get into some of the basics. We're going to be working with the probability of more complex events in this section. First of all, define the probability of the union of two sets, E and F, in sample space S. We're going to use the union rule for counting that we've already learned back in section 2. So that's good news. Nothing new here. And that rule is that the probability of the union of two events, E and F, is the probability of E plus the probability of F minus the probability of the intersection of E and F. So for example, when you're playing American Roulette, the attendant spins a marble that lands in one of the 38 slots in a revolving turntable. The slots are numbered 1 to 36, and then there's two additional slots that are labeled 0 and 00, and those are painted green. Half of the other slots are colored red, and the half are colored black. In roulette, the slots that are labeled 0 and 00 are not considered to be even or odd. So we're going to find the probability that the marble will land on a red or even number. Pause the recording, see if you can do this using the rule we just talked about, then resume the recording to see how you did. Okay, the probability of red is 18 out of 38. They're numbers 1 through 36. Half of those are colored red, so 18 is half of 36. The probability of an even number is also 18 out of 38. And then the probability of the intersection is 8 out of 38. Now, if you're wondering how we figured that out, you've got a diagram of the roulette wheel there on the page, and you just need to count how many of the reds are also even. And there's 8 of them. So using our counting rule, we add the probability of the red plus the probability of even, and we subtract out the intersection. 18 plus 18 minus 8 is 36 minus 8, which gives us 28. So 28 over 38, and reduce that, we get 14 out of 19. Here's another example. Suppose you roll 2 fair dice. We're going to find some probabilities here. The first die, first of all, find the probability that the first die shows a 2, or that the sum of the result is 6 or 7. Pause the recording to try this. Let me give you a hint. It's a really good idea to make yourself a chart of the different outcomes of the roll of 2 dice. Pause the recording, give this a try, and resume to check your answer. Okay, here's the chart I was talking about, and we've got the first die and the second die, so you can see we actually have the 2 next to each other, like you have 1 and 1, 1 and 2, 1 and 3. And the part that's highlighted in red are the ones where 2 was the first die roll. And the part highlighted in blue is the rolls where the sum resulted in a 6 or 7. Now, once we've got that, it's pretty easy to do the rest. The probability of event A, that the first one is a 2, is 6 out of 36. The probability that the sum of the 2 is 6 or 7 is 11 out of 36. And the intersection, I like the way they colored it here. You can see it really easy. There's two events in the intersection. So we've got 2, 4, and 2, 5, and that's 2 out of 36. So using our rule, we're going to do 6 over 36 plus 11 over 36 minus 2 over 36, which gives us 15 over 36, or 5/12. Now see if you can find the probability that the sum is 11, or the second die shows a 5. I would use the same chart and kind of do the same method for this. Pause the recording, give it a try, and resume the recording to see how you did. Okay, again, using the chart, the probability that the sum is 11 is 2 out of 36. The probability that the second die shows a 5 is 6 out of 36. And the probability of those two events happening together is only 1 out of 36. So putting all that together using our counting principle, we get 2 over 36 plus 6 over 36 minus 1 over 36, which results in 7 over 36. Remember that disjoint events cannot happen at the same time. So the intersection of two disjoint events is the empty set. And applying the addition rule gives us the following rule for disjoint sets. So for disjoint sets E and F, the probability of E or F is the probability of E plus the probability of F. We don't subtract the intersection because there is no intersection. So assume that the probability of a couple having a baby boy is the same as the probability of a couple having a baby girl. If the couple has 3 children, find the probability that at least 2 of them are girls. Pause the recording, give this a try, and resume the recording to see how you did. Okay, the event of having at least 2 girls is the union of 2 events. E, the family has exactly 2, and F, the family has exactly 3. And they are disjoint. You cannot have 2 girls and 3 girls at the same time in a family of 3 children. So the sample space for a family with 3 children is this. We've seen this before in a previous section. The probability of 2 girls, there's 3 of those out of 8. And the probability of having 3 girls is 1 out of 8. So adding those together, 3 eighths plus 1 eighth gives us 4 eighths, which is 1/2. Okay, the complement rule. By the definition of complement, E prime for any event E in the sample space, S, E combined with E prime equals S, and E intersection E prime is the empty set. In other words, remember, the complement is just the opposite. Whatever is in E, whatever's not in E, rather, is in the complement of E, so they're opposites. When you put them together, you get the entire sample space. And when you look at their intersection, it's the empty set. They don't intersect because they're actually opposites. Now the intersection, because the intersection is the empty set, that makes an event and its complement disjoint. In other words, you can't have them both happen at the same time. So the probability of E or E prime is the probability of E plus the probability of E prime. However, the union of the two, we already said, is the sample space, and the probability of the sample space is 1. In other words, the probability of something happening that's in the sample space is always 1. One of those things has to happen. So the probability of E or E prime equals 1. And all of that to get this rule, called the complement rule. For any event E, the probability of E prime is 1 minus the probability of E. And the probability of E is 1 minus the probability of E prime. In other words, if you know the probability that something is going to happen, if you subtract that from 1, that gives you the probability that it's not going to happen. Okay, here we have another example. If a fair die is rolled, what is the probability that any number but 5 will come up? Now I want you to use the rule we just talked about. See if you can do this on your own. Pause the recording and then resume to check your answer. So the probability that 5 will come up is 1 out of 6. The probability that any other number will come up is 1 minus 1/6 or 5/6. Now you may be thinking, well, it's kind of silly to use that rule for this particular problem because it's pretty easy to figure out that any number of 5, that only leaves 5 other numbers, 5 out of 6. But we're trying this out on a very simple problem. This can help us on more complicated problems and make things a lot easier. In fact, here's another problem that it's a little easier to use this rule that we just talked about. This time we're going to roll 2 fair die and find the probability that the sum of the numbers now showing on the die is greater than 3. Now, pause the recording, see if you can work this out, and then resume to check your answer. Okay, now one way we could do this is we could calculate the probability that the sum is 4 and 5 and 6 and 7, 8, 9, 10, 11, and 12, figure all those out, and then add those probabilities all together. Or we could find the probability that the sum is actually less than or equal to 3, which would either be 2 or 3. Find those two probabilities, add them together, and subtract that from 1. In this case, that's going to be a much faster way to do the problem and more efficient. So the sum that it's less than or equal to 3 Is the probability that the sum is 2 or the probability that it's 3? The probability that you get a sum of 2 is 1 out of 36. The probability that the 2 dice will add up to 3 is 2 out of 36. 1 plus 2 is 3, so that gives us 3 out of 36, or 1/12. Now we just subtract 1/12 from 1, and we get 11/12. So when you roll 2 fair die, the probability that the sum that you're going to get is greater than 3 is 11/12. Okay, sometimes we hear probabilities expressed in terms of odds. Now, probability is the likelihood that something will happen. Odds, on the other hand, are a comparison of what you want to happen versus the opposite, what you don't want to happen. For example, let's say that the probability of an event is 4/5. Then the probability that the event will not occur is 1/5. These probabilities predict that the event will occur 4 out of 5 times and will not occur 1 out of 5 times. So the odds in favor are 4 to 1. So here's the rule for odds. The odds in favor of any event are defined as the ratio of probability of E to probability of E prime. And this is fine as long as E prime, probability of E prime is not 0. So let's try an example. Suppose that the weatherman says that the possibility or probability of rain tomorrow is 1/3. We're going to find the odds in favor of rain tomorrow. Now, I want you to pause the recording, see if you can do this, and then resume to check your solution. So E is going to be the event rain tomorrow, and then E prime will be the event no rain tomorrow. The probability of E is 1/3, which means the probability that it won't rain is 2/3. Because remember, the probabilities always have to add up to 1. So by the definition, we take the probability that it will rain and we divide it by the probability that it won't rain. So 1/3 divided by 2/3, and that gives us 1/2, which is written as 1 to 2 or with the colon in between. So the odds that it will rain tomorrow are in favor of rain tomorrow are 1 to 2. On the other hand, the odds that it will not rain tomorrow, or the odds against rain, or the odds in favor of no rain, are 2/3 over 1/3, which is 2 over 1, so 2 to 1. Now, if the odds in favor of an event are 3 to 5, then the probability of the event must be 3/8. And the probability of the complement of the event must be 5/8, because remember, the first number tells you how many times the event would happen, the last how many it won't. If you add them together, it gives you the total number of occurrences. So this gives us this following generalization. If the odds favoring an event are m to n, then the probability of E is m over m plus n, and the probability of E prime is n over m plus n. So let's try this out. Often weather forecasters give the probability in terms of percentage. So suppose the weather forecaster says there's a 40% chance that it will snow tomorrow. We want to find the odds of snow tomorrow. Pause this recording, see if you can do it using the rule we just talked about, and then resume the recording to check your answer. Okay, so E is going to be snow tomorrow, and E prime is going to be no snow tomorrow. The probability of E is 40%, which as a decimal is 0.4, or as a fraction is 4/10. The probability of no snow is 60%, or 0.6, which is 6/10. So by the definition of odds in favor, so the odds in favor of snow are 4/10 over 6/10, or 4/6, which is 2/3. So that's written 2 to 3. So the odds in favor of snow are 2 to 3. By the way, you need to put your final fraction in lowest terms when you're communicating the odds. Now, the odds that a particular bid will be the low bid are 4 to 5. Find the probability that the bid will be the low bid. So this time we're given the odds and we need to work backwards and find the probability. Now this time we are going to use that rule that we talked about a minute ago. Pause the recording, give this a try, and resume the recording to check your answer. The odds of 4 to 5 show that 4 favorable chances are going to occur, 5 non-favorable, so that gives us a total of 9 chances. So the probability that the bid will be the low bid be 4 over 4 plus 5, or 4/9. For part B, find the odds against that bid being the low bid. So now this time we're finding the odds. Now we know the probability for E. Now we want to know the odds, but the odds against. So the odds in favor of E prime in this case. Pause the recording, see if you can do this, and resume the recording to check your answer. There's a 5/9 chance that the bid will not be the low bid. We know that because we found earlier there was a 4/9 chance that the bid would be. So what's left is 5 out of 9. So the odds against are going to be the probability that it won't be the low bid over the probability that it will be. So 5/9 over 4/9, which gives us the odds of 5 to 4. Here's another example. Let A represent that the driver in a fatal crash was 24 years old or younger. Let B represent that the driver had a blood alcohol content, or BAC, of 0.08% or higher. From data on fatal crashes in the year of 2010 from the U.S. National Highway Traffic Safety Administration, we have these probabilities. So the probability that the driver was 24 or younger is 0.2077. The probability that they had the blood alcohol content of 0.08% or higher was 0.2180, and the probability that both are occurring at the same time is 0.0536. Part A, find the probability that the driver was 25 years or older and had a blood alcohol content level below 0.08. Okay, pause the recording, give this a try, and resume the recording to see how you did. So the best way to do this is to organize our information into a Venn diagram as we've done before. And remember, when we do that, we start with the and. So we put the intersection of A and B of being 25 or younger and a blood alcohol content of 0.08 or higher. We put that in the middle, and then we subtract to find what's left, for what crashes were only involving the driver who was 24 years or younger, or what only involved the higher blood alcohol content level. So we subtract to get those. And what we were supposed to find is the probability that of A prime, or the intersection of A prime, B prime. In other words, that the driver was both older than 24 years old and had a lower blood alcohol content than 0.08. And we do that by finding the rectangle outside of the two circles. We use the fact that all of our probabilities need to add up to 1, so we can add the numbers inside the circles and subtract from 1, and we get 0.6279, meaning the probability that a driver of a fatal crash is 25 or older and has a blood alcohol content below 0.08 is 0.6279. Okay, so for part B, find the probability that a driver in a fatal crash is 25 or older or has a blood alcohol content below 0.08. So this time we're finding the union, the or. Pause the recording, give this a try, and resume the recording to see how you did. So what we're going to do is we're going to combine the not A and the not B together. And in doing that, we get 0.6279, 0.1541, 0.1644. So notice we're really combining everything except the intersection, and we get 0.9464. Okay, example 10, data from 2012 Forbes magazine survey of the 100 highest paid chief executive officers, or CEOs, is cross-classified by age in years and annual compensation in millions of dollars. E is going to be the event that the CEO earns less than $25 million, and F is going to be the event that the CEO's age is in the 60s. And you can see the chart there that it's kind of like a contingency table. It spells it all out for you. So we're going to find the probability of E. Pause the recording, give this a try, and resume the recording to check your answer. Okay, so to find E, we just need to find the total number where the pay is less than 25 million for all the different age groups. And adding those up, actually they give us the total at the bottom. It's 60, so we have a total of 60. And there were 100 executives surveyed. So we have 60 over 100, or 0.6. And the probability of E intersection with F, they earn less than 25 million, and they are in their 60s. Pause the recording, give this a try, resume the recording to check your answer. So now we're going to look at the numbers that satisfy both conditions. There are 31 in the column for less than 25 and the row for age 60. So you see that in bright blue. And that's what we're looking for. We're looking for those in their 60s that earn less than 25 million. And the intersection of that is 31. 31 out of 100 is 0.31. And then for C, we're going to find the probability of the union of the two events. So pause the recording, give this a try, and resume the recording to check your answer. So we're going to use the additive rule. We know that the probability of E is 0.6. We can find the probability of F. So there were 45, so that's 0.45 CEOs who were in their 60s. And we're going to add those together, but we're also going to subtract the intersection, because remember, this is the group that if you just add those two things together, they get counted twice. So we do need to subtract the intersection, and that gives us a result of 0.74. The rest of this is extra practice. Pause the recording and give these problems a try. Resume the recording to see how you did, and continue in this manner through the rest of the recording.